This is our code example of the bridge pattern. And the basic idea behind this application is that we want to be able to send some sort of message. Now, initially, our application is just going to support SMS and email messages. But we expect great success, and with that great success, we expect to have to send all sorts of different kinds of message types. We'll probably have to use all sorts of different chat APIs and probably create our own API as well. So there's going to be a lot of things that go on with sending different messages and users being able to choose whatever message type or provider they like. So we expect a lot of churn and change in that area, but we don't want that change to have to filter through all of the application code. We want to try to isolate that. So we're going to use a bridge pattern to isolate all the details of that messaging away from the rest of the application. So in our application, we have an interface called iMessage. And at this point, it's very simple. It has one method in it called sendMessage. We have two classes that are going to implement iMessage, the SMS message class and the email message class. And we'll have a message type enum. And at this point, it'll just have the two options, SMS and email. Then we'll have our bridge class, which I've called message controller. It'll have a property for the message, which is actually an object that implements iMessage. And we also have two methods, one called setMessageType, which the client application can set the message type to be used, whether it be email or SMS. And then a second method called sendMessage. Now the sendMessage on the message controller is not necessarily the same signature as the sendMessage on iMessage. Message controller does not implement the iMessage interface. It has that one message property that is of type iMessage, but the controller itself does not implement iMessage. And then we have our form or our client that will use the message controller. So the flow will be it wants to set the message type, and then it will send the message. We'll take a look at iMessage, which very simply has a sendMessage method. And there's a string for a to and a string for the message. Obviously, as we expand, we'll probably want to expand this message signature as well, and we may need to put in some other things for authentication and the like. Our email message descends from iMessage and implements sendMessage. As you can see, our implementation is a little bit lacking at this point. We've left that for you. The SMS message also implements iMessage. And the email message and the SMS message are known as concrete implementers in a bridge pattern. So that may be a piece of terminology that you'll see from time to time. So the SMS message implements iMessage by implementing the method sendMessage. And maybe we'll use Twilio for that implementation. Again, we're a little light on the implementation tonight. Then we have our message controller. And this is really the bridge class. It has our member for message, which is of type iMessage, meaning that any object that we have here will implement the iMessage interface. Then we have the method setMessageType, and depending on which message type, it'll create a message object of either email message or SMS message. So if the user tells us that they want to send an SMS message, we'll create a concrete implementation class of SMS message type. If they want to send email, we'll create an email message type. Then we also have a public method called sendMessage. And again, it takes parameters for to and message. And it will simply, on the message object that it has, call sendMessage. And note, the message controller does not implement iMessage. So here's our little messaging form that we're going to have. And we have radios for the user to choose what type of message, either SMS or email, and a to area, pre-populated with a bogus SMS phone number, and a message area. This is really a pretty poor user interface. And the reason is SMS and email messages really have very different characteristics in terms of what they expect for a to and for a message. Obviously, an SMS expects a phone number for a to property, whereas email expects a valid email address. And we have a free-form entry for either one of those. We'd really like to hook this up to some sort of address book probably, so that we don't have users mistyping email addresses, which they do all the time, or attempting to remember phone numbers, because who actually remembers phone numbers anymore? Everybody uses address books. Also in the message area, it's a fairly large text box. And of course, you're familiar SMS is limited to the number of characters we can send, and I'll bet you this text box does not limit how many characters that can be sent for SMS. Of course, email doesn't have that limitation. So essentially, this form is ill-suited for either SMS or email because it makes compromises to support both. So just a little bit of a usability hint, you have to think about how the user will use the form and try to avoid allowing them to make errors when they use the form. So we do have this ugly messaging form, and on the Send button, if the radio button SMS is checked, we'll call the message controller, and we'll set the message type, and we'll set it to message type SMS. Otherwise, they're sending an email, so we'll call the message controller and set the message type to email. After we've set the message type, we'll send the message, and we'll read those nasty text fields for to and message. And again, we're calling send message on the message controller. And the message controller is the thing that actually calls send message on the iMessage interface. And that's really the whole point of the bridge pattern. The application will only know this end of it. It'll only know the send message and the set message methods of that message controller. It won't know the ins and outs of even iMessage, so that it won't have to worry about any of the changes that are going to occur on that end. For instance, we may need authentication, and probably do need authentication for email. But our application doesn't necessarily have to know anything about that. It may come from a database configuration for a user, or it may come from a config file, and the message controller can deal with that, or the email message class can deal with that. But our application doesn't want to know anything about that, and of course, when we go into other APIs, their authentication schemes may differ. So we don't want to have the application have to understand all of those different iterations and requirements of the different messaging schemes. The application really just wants to know, I'm going to send a message of this type, and here's the message, just send it. So that's really that division of concerns and that isolation that the bridge pattern gives us.